Well, welcome. I'm here to share with you some changes, what's new in Swift 4.2. You're going to love what I have to share with you because as we've seen Swift move from its very first version to 2, 3, 4, the big monstrous changes have gone down. Like I remember when Swift changed the way that arrays were handled, and all my code bases had to be updated to the new way. And, there was kind of been these big shock waves into how Swift has been working, but it's become more stable over time. And in Swift 4.2, there's some really awesome updates that don't have any big earth-shattering changes as into like it's going to break your existing code, but it's just some awesome bonus features that are amazing that I think you'll find really practical and helpful. So to learn these and test them all out, let's go ahead and open up Xcode. We want to create a new playground so we can mess around with all this. So I'll go ahead and pick one of those. I'm just going to throw it onto my desktop. So we want to be dealing with Swift 4.2, and the first thing that I want to be talking about here is randomness. So if you've ever done random numbers before, and I'm going to do an import foundation here so that we have this, but before what you had to do is you have to say arc4 underscore random, right? Do you remember doing this to go get random numbers and stuff? Very annoying to go get a random number. In Swift 4, it is so easy. All you have to do is take a particular type and you just say that you want a random number from it. So for example, if I want a random number that's a double, I just say double dot random, and then I just have to choose a range in which I want this random number to be. So for a double, typically you might see something like this. You would want a number between 0 and 1, right? Because you just want some number there. So you can say, you have to give a range here. You can say 0 dot 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 1. And this is saying any number between 0 and 1. And I'm going to go ahead and change my playground to say automatically run so we can see what the outputs are going to be over here. And I'll give ourselves some more space to see that. So there you have it. I picked up some random number, 0.302. I'm sure yours is different. Like if I go ahead and delete some code here and bring this back, it'll pick a new random number. Now all of a sudden it's 0.746. But this is so simple, and it doesn't have to be between 0 and 1. Like if I wanted it between 0 and 10, we can totally do that. And all of a sudden now when we do this, well, you're supposed to change a random number. Come on. There we go. Now it's 9.844 or something like that, right? So with these ranges, it doesn't have to be between 0 and 10. If you do the minus sign here, this basically says up to 10, so it won't go up to the number 10. It would go up to the number 9 here. I think you'd best see this represented if we do, instead of doubles, let's do an int here. So we're going to say int dot random. Okay, and then for this random range here, let's say, maybe just 0 dot dot greater than, and let's do the number 3. So the really only possibilities of this should be 0, 1, and 2. And in fact, if I go ahead and just copy and paste this a bunch of times, I want you to see that the output is never going to be 3 on this. So let's go ahead and see this output, and look at that, 0, 2, 1, that's all it's going to be. Whereas if these were all dots, it would go up to 3, right? So if I go ahead and just make some changes, look at that, even you can see at the top, it's already picking the number 3 and whatnot there. Oh, whoa, we made it through this whole list without getting the number 3. That's really odd, but then all of a sudden we update and boom, there's 3 different. That's the whole thing with randomness, right? You never know what it is that you're going to get. Okay, so you can do this on all number types, doubles, ints, floats. You can do this as well. Something also pretty interesting, you can do this with Booleans. And you might be saying, well, with a Boolean, like, what is supposed to be all that random? Well, it's really just true or false. You can randomly pick yes or no kind of situation. All you do is say bool.random. You don't have to specify a range because it's only a yes or a no. And so you can see we get that. And let's do the same thing where we kind of copy and paste this a few times. Look at that, true, false, it's going back and forth there. Okay, so that's randomness. Again, I think this is so much cleaner from what we saw, because before when you did like the arc4 random and you wanted to get it into a double, you had to do this conversion. And it wasn't just an irregular int even, I think it was an int 32. So this, in my opinion, is a big plus. Now, we had just talked about Booleans at the end here. I'm going to keep moving forward there, something that's really cool with Booleans now is that you can toggle a Boolean, if it's true, switch it to false, or it's false, switch it to true, which is a very common thing that people want with Booleans. And so to show an example of this, let's say I have an app that's keeping track of someone's time, and they're either clocked in or they're clocked out. So there's going to be a Boolean called clocked in, and we can set this initially equal to true. And let's say, whenever someone hits a button that we want to change clocked in to its opposite value, right? We want to flip that over. Well, before we would have had to do some sort of check where we'd say, if clocked in, right? And then it's like, then I want clocked in to be equal to false. And then we'd have to set up our else situation here, right? And then we'd say clocked in is equal to true. And this code isn't awful, but now in Swift 4.2, all we have to do is just say clocked in dot toggle. That's it. That's really all we have to do to make this happen. And so what this does is, and I'll show you here, I'm going to type out clocked in so that you can see how it goes. It clocked in started out true, and then I say toggle, and now all of a sudden it switches that to false, and then comes down here and switches it back to true because it was false there. But same thing goes if this was false, it would switch this thing over to true. Okay, look at that, boom, it switches it right there. So as you can tell, this singular line of code versus these 5 lines of code, it's a whole lot simpler. So this, again, really practical things that I think makes coding in Swift that much better. I'm pretty excited about these changes, if you couldn't tell. The next one has to do somewhat with randomness, but specifically for arrays. So to set up this discussion, I'm going to make an array of dogs, which is just going to be an array of strings. So let's have Fido, and let's have Sarah, and let's also get Dan. Okay. So here's an array of 3 different dogs that we have. Now let's say, we wanted to pick a random dog from this list. Well, we could go ahead and, use our new random abilities and say, dogs, and then go ahead and get an int dot random, and we would provide the range of 0 dot dot dot, and then open parentheses and say dogs dot count, right? This would go and get us a random dog element if we go ahead and copy and paste this. Oh, it's not 11 execution. I got this error before. I believe this is an Xcode bug, but we'll just go ahead and run the code, see if this works. Okay, Xcode got out of its spiral. But anyways, you can see this code picks a random dog from the list there. Pretty awesome stuff, but it doesn't have to be this complicated, right? Even though we're using this awesome int random that makes it that much easier, now in Swift 4, all you have to do is say dogs dot, and then we want random element, bam, just like that. It picks out a random dog for us. So we can copy and paste this a couple of times, and you'll see it picking a random dog a bunch. That's all you have to do. If you just want one random thing from your array, you just say random element, and it does all the work of figuring out how many you have and picking one at random. Really cool stuff. Again, it's like, yeah, you could do this on your own, but it just makes it that much simpler. Also connected in the array world, let's say we have this array of dogs and we wanted it to be mixed up. We can actually shuffle the values that are there. So if we say dogs dot shuffle, and you can see there's shuffle and shuffled. The big difference between these two is shuffled returns back an array. And it basically shuffles the existing array, gets a new one, and sends it back as an object, whereas shuffle, this one mixes up the existing array. So you can see, for example, dogs, when it first was listed out here, it went Fido, Sarah, Dan. Then when we did the shuffle, all of a sudden it's Dan, Fido, Sarah. I'm trying to get the update here so that you can see. There we go. So now it's showing Dan, Fido, Sarah here when you've shuffled it. So you've actually changed what the variable is here when you do the shuffle. Now with the shuffled, with a D, this passes back an array of, random, an array that's, all been shuffled up differently. But you'll see, so this one's different. Dan and Sarah basically switch places, but the underlying dogs array never actually changed it, just spit back something. So you could, the big positive is you could, put this new shuffled thing into a new array. So we could say mixed dogs is equal to dogs.shuffled. And so now this mixed dogs can hold, the random portion if we wanted to do that. And I'll say also here, if you are going to do a shuffle on something, it has to be an array, right? So if I tried to have a constant here called dogs and I tried to do this dot shuffle on it, you'll see that I'll get an error here and it's saying, hey, dogs is immutable. You can't change this thing. Do you want to change that to a variable? And yes, I do. And then all of a sudden that is working there. Okay. One more thing to go along with arrays here. This doesn't have to do with randomness, but it's a way to sort of, if you've got a big array of something that you can check to see if they measure up or, pass some sort of condition. This is called all satisfy. So you take an array and you can say on it dot all satisfy. And if you go ahead and hit enter on this completion handler, basically this would go through, let's go to the top here, each individual dog, and we would have to return back a Boolean, true or false, about whether this satisfied some condition. So let's say we wanted to tell, do all the dog names at least 3 characters long. So we want to return back, basically if dog.count, that's going to give us how many characters are there, is greater than or equal to 3. Okay, so if we go ahead and run this, if Xcode is going to behave itself, there we go. You can see this turns back true because it says, hey, all the items in this array, their name is at least greater than 3. Now let's say I up this and I want to say, are all the names at least greater than 4? Okay, so let's make this change and test out the code. Now you can see it's false because we have Dan here that's only 3. But if I, switch Dan to be Danny, something like that, all of a sudden, that switches to true because, that satisfies those requests. Now, if you want to, this is sort of the long way to do this and you can really specify. But if you just really shorthand want to do this a lot easier, you can do the exact same thing by just saying dogs.all satisfy. And then after the all satisfy, do your curly brackets, and by using the $0, this represents the element that you're currently looking at. You could just say $0.count greater than or equal to 4. Okay, and so this line of code is the exact same thing as this line of code. They both do the exact same thing of checking to see whether this all works, and in both situations it's going to return back a Boolean for you about true or false, whether you can use that. Okay. Then really the last thing that I'd like to share with you is you can now add warnings or errors into your code. So this is kind of a good situation, whereas if you're working on some code, let's say here I'm working with this dogs thing and it's like, I got to remind myself that I want to come back and make this the shorthand version. So I'm going to do a hash warning. Okay, and then you do open and close parentheses and then put a string in there that you want to remind yourself some sort of warning. So I'm going to say here, make this shorthand, something like that. Essentially what this does is you can add your own custom warning. So now, whenever it is you're going to go run your app, you can go check your warnings here and it's like, oh, look, I have a warning here. And then you can see I was trying to tell myself that I need to make this shorthand. This is like, if you've ever seen people do like in their commented out code, adding like to-dos, this is essentially a similar version of that you can leave notes for yourself to say, hey, I need to, come back and do something here. Now, also, the other thing that you can do is you can produce errors in your code. So if you say, instead of hash warning, you do hash all lowercase error. Same thing with parentheses in a string, and we'll just say this is broken, something like that. This creates an error, which straight up means that your code's not even going to compile, right? Like if this was in an iPhone app, we wouldn't be able to run the iPhone app, and you might be saying, why in the world would you ever want to do this to your own code? Well, you could personally do this if it's like, do not run this code until I've figured out X thing. That seems like a really weird situation. I can't really think of a time you would get yourself into that. But Paul Hudson, who is a great Swift instructor, he had an awesome example on his blog of if you were making some sort of SDK or API handler that someone could import to your project, maybe via CocoaPods or something, but where someone needed to enter an API key, you could make one of these error that says like, enter your API key here, and this would essentially, if someone has like, var API is equal to, and it's like enter key, something like that, right? So you would ship your code with this so that the user could not use your SDK until they came and addressed this situation. It's kind of one of those situations like you should not be using this unless you've updated this thing. So I thought that was a pretty cool way to describe how that happened. So there you have it. That's what's new in Swift 4.2. I hope you enjoyed learning all about that. Again, very practical things that add to our code, but don't make massive changes that uproot everything that we've done. I'm really impressed with Swift 4.2. And as Apple moves closer and closer to Swift 5 with ABI compatibility, really excited to see that come. So there you have it. If you have any questions, please leave them as a comment to the video.